Right, finally found the right slides. Okay. So before we think about growing more winter feed, I suppose it seems like a dumb thing to say up the front, but do you actually need to grow more feed? Because just because it's getting into winter and it's cold, things are pretty lean on the farm normally. But I suppose because a lot of people have been through pretty dry conditions in most of Victoria, and a lot of people have reduced their stocking rate. So some people I know are down 30-40% in stock numbers. So depending on what feed demand is on your property this winter, and how well your pastures are recovered from the dry, maybe you may not have to do anything. But so it's worthwhile just doing a bit of stock take and a quick feed budget on the back of an envelope, and working out how much feeds across the farm. And some areas are probably still recovering from the dry. They might only have 400 or 500 kgs on the farm, which is just like nearly a centimetre. Other paddocks, other farms may be bouncing around 800 or 1,000 if they're lucky. So do a bit of a stock take. What's growing around the farm? How well is it recovered? Is it all filled in yet? Is there still gaps? That sort of thing in the paddock. Stock numbers, feed demand, and what are the pasture growth rates doing? You can measure them yourself if you're not sure what the pasture growth rates are and how likely it is that you'll grow enough feed over the coming months, particularly if you're leading up to lambing in July or August. You can use a tool called Pasture Some Space when it comes back online, and that was a really great product which I highly recommend once it's available again. It's just in a bit of a transition to being given to or sold to a private provider from used to be CSIRO in WA. That tool actually has a satellite that goes over, and you get weekly updates on feed on offer and pasture growth. And if you subscribe, you'll get it at your farm level. If you don't subscribe, you just get shire level information, which is better than nothing. At least it puts you in the ballpark about what growth rates are doing. But you can measure it yourself. If you go out, measure a paddock, put a post or a tread in or something where you can go back to the same spot, come back in a week's time, 2 weeks' time, measure it again, and you can quickly work out your own growth rates, or get you in the ballpark for feed budgets. So the next thing is just thinking about what animals have to be going into those paddocks. Is it just dry sheep or lambing ewes? When are they going to be lambing? Are they already lambing, lactating? How much feed do we need? Do we, if it's only dry sheep, they'll probably get by with just a bit more than that. If it's single bearing ewes, about your lambing, then they're going to need 1,000. Couple of centimetres, and then if they're can't see my own thing there, we need about up here. If we've got twinners, they're going to need up around that 5 centimetres. So who's going to need the feed, and have we got enough time to grow that feed by the time they have to go in there without doing anything, or do we need to do something to actually get that feed wedge sort of in front of them? So if you think about pasture growth rates, if you're not sure what sort of growth rates to expect, so you can do your little feed budgets. I've just got a pasture curve here for Bendigo with a well-fertilised Phalaris clover pasture, and a similar one for Hamilton, but for ryegrass. So these are the kilos of dry matter per hectare per day, and we can see, well-fertilised pasture might be growing at 15 to 20 kilos through the winter around here. And similarly over here in Hamilton, it might be doing a little bit better, a bit milder in the winter. But you can see the effect of this line down here is a low fertility pasture, but the same good species, but just being held back by low phosphorus or something like that. But you can see here that we're probably growing, the growth rate's half that of a well-fertilised pasture. So you might go from growing 10 kilos a day to 20 kilos a day just by fixing up phosphorus or potassium or whatever the other macronutrients might be. So we can do something about soil fertility, and species will obviously affect the shape of the curve, and moisture and temperature. So out this end, we know, it's usually not temperature, it's moisture that's holding things back. And then obviously when we get into winter, usually got moisture, but it's just temperature that are holding things back. And it depends what district you're in, how much that is being held back. So if we want to try and grow more feed through that winter sort of tight pinch area, that's the sort of that's the bit that I suppose defines our stocking rate and that sort of thing, because it's the tight part of the year. We've got a few options. One is rotational grazing or autumn saving, and Andrew Wales has been talking about autumn saving. But we can use rotational grazing or autumn saving to try and create a feed wedge. that'll increase pasture growth rates, and we can build up that feed for animals with high feed demand, such as the lambing ewes. And this is an example of someone doing a bit of autumn saving. They've had stock in a containment area, they're just using their laneways for containment, just holding them off, just trying to get that feed away, building up feed for later on in the year when they lamb. But the other options we've got are nitrogen, and whether it's urea or liquid forms, and gibberellic acid, which is just a crystal that we mix up and put on with a boom spray. So I've just got two brand names there, one's ProGib and one's Rise Up. Okay, so if we've got a good pasture base and we've got good soil fertility, we've got the options to use nitrogen or gibberellic acid and get really good responses. If we haven't got good fertility and we haven't got quite so good species, then we might get a response, but it just won't be the optimum. So it still might be economic, but obviously if we've got some better pastures we can line up for these products, we're going to get a better response. So this is just kilos of pasture again with that Hamilton curve. So here's the good fertility curve. So I suppose late May, early June, when we've got moisture and it's still not too cold, we've got the option to use nitrogen to grow a bulk of feed, so we can be putting that on in here. And this little dotted line's showing you, if we put nitrogen on there, late May, early June, this is sort of the extra feed we could grow. So we might grow from growing 20 kilos a day to maybe 30 kilos a day growth rate. So it's pretty massive. And we're just building up this feed and filling in that little feed gap there. If it's getting a bit too late for nitrogen and we're thinking it's getting a bit too cold, and this depends on where you live of course, then gibberellic acid becomes a good option. It works well when it's colder, so we can use it from sort of June to mid-August, and then after that it's sort of getting warmer and we won't get as good a results from the gibberellic acid. So we've got those two options, and I'll talk about later where we can combine them or use them separately. Yeah. No. Every question was, is this just applicable to Southwest Victoria? No, don't panic. I did take Bendigo on the other slides. So it's really about moisture and temperature, which is what Jane was talking about with the database. So these are just I suppose in terms of, you hear a lot about nitrogen, gibberellic acid, but often people aren't sure where they fit. So this is just me trying to show where they might fit in. And I suppose the other thing is if you're lambing in late July or August, if the conditions are right, you could have put N out here. If you're getting close to lambing and you're running out of time, often people think, well, I've got to go to gibberellic acid because I've only got 3 weeks before lambing, and gibberellic acid will work in that time. Where nitrogen, we're really looking at a 6 weeks lead-in time before we get the full response, that is. If we put it out and then graze it in 3 weeks, we won't be getting the full response, the full benefit.
Gibberellic acid, it performs primarily best, I understand, with flares, particularly the older varieties of flares. What about with these tetraploid ryegrasses? You get a worthwhile return in the ground?
Yep. So the.
That have already got this winter growth gene.
Yep. So the question was just about gibberellic acid, which I'll cover that in a bit more detail in a minute, but. So whether they're like old Australian Phalaris or winter active cultivars, it works really well at a low rate. With the ryegrasses and the cockswoods, for example, it works well, but you just use more per hectare. So it still works on the it works on most species. It just depends on how much bulk you can grow depending on the species. That's all. So if you've got something if you've got a good grass pasture, nitrogen and gibberellic acid will give you more bulk, where if you've got a weedy or more clover dominant pasture, you just won't grow the bulk. So they still might respond, but you just won't grow as much. So the cost of it it's not as cost effective. But it'll work on those ryegrasses. Yeah. I'll come to that. Yeah. Yep. So nitrogen. So if we're going to use nitrogen, we want to have some good pastures, hopefully with some decent grasses in them. Doesn't matter whether they're annual or perennial. It could be annual rye, it could be perennial rye. We'll just grow more bulk if we've got some grass sitting in there. And we want to have good background soil fertility, so we haven't got anything holding back the response. When can we use it? So moisture and temperature are important. So we want to wait after the autumn break. We wouldn't use it straight away because it's probably too dry, and there's also some nitrogen in the system from mineralisation. So if we've had a dry summer, there'll be N kicking around when the organic material is broken down. So when we get the autumn break, we have a flush of nitrogen's usually released. So you wouldn't want to use it straight away anyway, even if it was wet enough. Waiting, a little bit of time is a sensible thing to do to use up the nitrogen that's in the soil, and then we'll get a better response. But we really need adequate moisture. So some parts of Victoria, people are sort of worried they still haven't had enough rain to wet up the profile really well. But as long as you know the root zone has got moisture in it and the plants are actively growing, and they're likely to regrow if you graze them, then you know it's okay to use N. So at the autumn break, it's usually touch and go, and you probably wouldn't want to use it then anyway because we've already got N kicking around in the system. So the pasture has to be growing. With our temperate grasses, it doesn't matter whether they're annual, perennial ryegrass, cocksfoot, fescue, phalaris, any other varieties. They'll grow, when the soil temps are above 4 degrees, they'll be growing. But to get better responses out of nitrogen there, you'd want to have the soil temp up around 8 to 10, which it is kicking around at the moment, and in some districts it might even be 12, so they've still got plenty of potential to use N if they've got the moisture. But some areas around that 8 to 10, so that's when you get good. If you could theoretically use it at 4 degrees soil temp, but you just won't get as good a results with it. For people with subtropical grasses, obviously they shut down when the soil temp drops down below 10. So apply after grazing a paddock. So if you're rotationally grazing, it works in really well because you might have just grazed the paddock off, and then you can put the N on after grazing and then not come back until the next rotation, which might be hopefully maybe 6 weeks in winter, which fits in perfectly with the time it takes for the nitrogen to give you a good response. And if you just come in earlier, you're not going to get the full response. Measuring soil temperature. Yeah, if you could, has anyone got a digital thermometer that they go out and, yep. Do you use it a lot? Monday mornings, yep. What's your soil temperature at 9 o'clock? Oh, okay, good, warm, yep. So you can easily go out and measure your soil temperature with one of these guys, a little digital thermometer. And if you haven't got one of those, you can have a look at the website Jane talked about, which the department looks after, and you'll have for those places in Victoria that soil temperature and soil moisture being tracked in those areas. But if you just want a bit more precision, grab one of these little guys and you can go out and measure it. A lot of the soil temperature stuff you read about is always like the 0 to 10 at 9 a.m. in the morning when people throw around soil temp figures. So this is what Jane showed you before. So I'm just going to look at Bainton, which we thought, well, this is a pretty cold place, 550 metres above sea level. And we've done a lot of work with nitrogen on Gerard Ryan's place, who's sitting there in the crowd. So if nitrogen's going to work this is pretty cold, so if nitrogen works here, then it's going to work pretty much in all these other places. I've been pretty confident. Because it gets pretty cold in the winter. So this is that graph again that Jane showed with Bainton, and the red line is that all a bit more noisy because we've got that's a topsoil, so it's changing in soil temperature during the day, and the other lines, which are a bit more stable during the day, are the deeper soil profiles. So that's going back to March up till yesterday, and as Jane said, it's sort of bouncing around, what is it, Jane, 8 to 10, 11 or something like that. But with these graphs, you can actually click on them to get a bit clearer picture. You can click on them to get less, just pull out the topsoil one and also look at a smaller time frame. So I've got rid of all those other lines. I'm just looking at the topsoil, 0 to 10, and you can see over the last 6 weeks or so was up around 13, 14. Then it started to get really cold, and then it sort of seemed to have got back up again and hanging around that 8, 10 degrees. And we can look at, if we go to the next one, that's just showing you over a day the sort of diurnal variation. And some days it could be 4 degrees difference between the high and the low of that day. So if you just do a check at 9 a.m. in the morning, that's what we usually talk about when we talk about soil temperature when you read all research trial information, that sort of stuff about responses. So it's still, oddly enough, this year, it's still reasonably warm and still capable of giving a nitrogen response at that climate, but other areas, like you said over there, might be 11 degrees, and some areas might be 12 degrees at 9 a.m, so easily warm enough for a nitrogen response. So how much N do we need? So a lot of the nitrogen work's been done in the dairy industry, and a lot of it's been done by a fellow called Richard Eckard, who's worked at Allenbank and University of Melbourne. So I'm sort of drawing on some of his data here. This is looking at nitrogen responses, and on this bottom axis is the 0 kilos of N up to 70 kilos of N. So I'm just talking about N, nitrogen. So if you think in urea, basically just double those numbers. So we're 0 to 70, and this is the percent of maximum pasture growth rate. So what they've tended to find is if you put a little bit on, you sort of get less reliable results, you don't get as much response. If you put on somewhere between 25 and 50 kgs of N, you're sort of getting into this part of the response curve, a bit more reliable responses. And then if you're putting on more than that, it's a diminishing return, so you're not growing any more grass and you're potentially losing nitrogen. If you've got leachy soils, like sandy soils, you might be losing some N through the profile. So you're no point in putting on heaps in one application, and if you put too little on, you probably won't get a good response either. So somewhere between 25 and 50 kgs is a good place to be operating. And it depends on how much extra grass you need to grow based on your feed budget, whether you put 25 on or 50 kgs. So what product? Doesn't bother me what product people use. I'd rather go for the cheapest. So usually urea is the cheapest source of nitrogen. But if you need other nutrients, and you may look at other products because of that. Some people are using ammonia sulfate, others might be using DAP. It just depends what other nutrients you're trying to put on at the same time. And look, it doesn't matter what. If you use the same rate of nitrogen, you should get the same response regardless of product. And even with chicken litter, I've had the same response where I've put on the amount of chicken litter and matched the nitrogen in chicken litter to urea. I've had exactly the same response. So that's a good sign. If you're using, just pick the cheapest product or what works for you depending on other nutrients. So here we are at Bainton. So like I said, it can get pretty cold in the winter. And these are just some results from a few years ago, 2015-17, looked at putting urea on 100 kgs of urea in late May, early June. So obviously once there was enough moisture and the pasture was growing and not moisture stressed, just timed it based on those conditions. Measured the response 6 to 8 weeks later, and these are the sorts of range in responses. Grew an extra 400 to 700 kgs per hectare, which equates to 8 kilos of dry matter per kilo of N, or 14 kilos of dry matter per kilo of N. And that was pretty similar, consistent with a lot of the dairy work. They're always looking at ryegrass in dairying systems, but 8 to 14, they often talk about 10 to 1 responses in the late autumn, and then if you've haven't got great species or slightly lower fertility, you might be getting down to 5 to 1. So if you sort of can think about those sorts of responses, then it allows you to do your budget to work out whether it's economic or not. Yeah, sorry.
What's the phosphorus level of that paddock?
Oh, about 20 or something. Yeah, so PK&S not limiting. Yeah. And you can see, can you see there, this is the sort of replicated experiment. This has had all the nutrients, so nothing limiting. And if you can see that line there, there's actually a string there, but this side's had urea and that hasn't. But it's a good phalaris pasture. It's responded really well. Can you see the difference? Yeah. So extra 600 kgs in that particular photo, which is it costs about 10 cents per kilo of dry matter, so pretty cheap. Oh, in this particular one, it was probably, I don't know, 70, 80? Yeah. But it doesn't have to be that strong when you put the urea on, as long as there's decent grasses there to respond, yeah.
Have you
I haven't in these trials, but just drawing on other people's experience. But did you want to make a comment or? Yep. Yep. Yeah. Look, and this is using urea. So once again, the timing's got to be a bit. You've got to be planning ahead a bit more to get the best results from it. And I suppose when I talk about gibberellic acid in a minute, a lot of people have been using the easy N type products because they can mix them with the gibberellic acid and get it out at the same time. So that's one reason why people are using those products. It is a dearer form of N, that's the only thing. So it just depends on the timing and how much extra feed you're trying to grow and how it fits into your system. But just the other thing I wanted to point out about nitrogen is that a lot of our a lot of pastures that were good are deteriorating and getting full of junky grasses like silvergrass. This is silvergrass. This is just near Seymour, Glenarua, 2012. I was doing some work over there. But it was a pasture that was in the autumn. The Phleris was quite small and stunted, and it wasn't that dominant. But there were plants there. But the silvergrass was quite dominant, and PK and S were all really good. But it was just a bit deprived of nitrogen. So a lot of our good pastures, potentially good pastures, are deprived of nitrogen and they're just not performing. So if we can somehow get the nitrogen cranked up, whether it's more clover or using urea or other products, then we'll get a lot more out of them. But all that happened in this particular trial was in the autumn, 25 kgs of N in urea form was added to that, and this one didn't have any urea, but the background PK&S is really high. And so by the spring, so really good N responses during the winter, and by the spring, the Phleris had then suddenly outcompeted the silvergrass. So it was just lack of N, it just wasn't doing much, and the silvergrass was getting the advantage because of the lack of N, and the landholder had been using simazine every now and then to try and clean the silvergrass up. It just kept coming back all the time. So it's just a really good example of if there's a nutrient constraint there holding back your good species, you may not have to be spraying out the weeds. So this was just a classic silvergrass hanging around because of low N, and it actually turned out there was a molybdenum deficiency going on in this paddock. It needed moly, so that was another reason why it was so N deficient. So don't forget about molybdenum too. We talk a lot about the macronutrients, but don't forget about moly.
What are your thoughts on soil testing versus tissue testing at relevant time thinking to identify what's actually in the land?
Yep, so the question is about tissue testing and soil testing. Soil testing is good for pH and macronutrients and some structural things. Leaf analysis is good for trace elements. So if you're not sure about moly, copper, boron, zinc, go leaf test. You get some of that information on a soil test, but leaf test is more accurate. Spring, leaf test in spring before the clover flowers. And soil test I usually go for spring too, just because the ground's soft and you get your results back before your autumn fertilising program. Is the question was about... Yep. Oh, so the question is about soil temperature. Is the data showing? Yeah, I don't know. We haven't got enough data from those sites that Jane's talking about. They've only been in for not even 18 months, I don't think, have they? Yeah, less than a year. Yep. Yep. But I mean, I suppose we can look at ambient temperature as opposed to soil temp. But yeah, because it's easy to get air temperature records than it is to get soil temp. So that's why these sites are going to be really great to have that information. So Jane, the cropping sites have been in for... So was the, Terry, that was the question was in relation to, does that mean we've got more option to use nitrogen because the soils are getting warmer? Is that? Yeah. Well, theoretically with climate change we're meant to be getting warmer winters, which is meant to help pasture growth and also more CO2, which is meant to help pasture growth too. So all the modelling shows that with climate change we would expect more winter growth, but more variable rainfall, and our spring's worse and autumn's worse, but we might get, so it's probably not much of a consolation, is it? Yeah. So if we're talking about nitrogen responses, if you're trying to plan for your situation what numbers to chuck into a little budget to work out the maths whether it's worthwhile or not, if you've got some good pastures with good background fertility, so some grass in there, it doesn't have to be wall-to-wall sown perennial, as long as there's some grasses there, because as I showed, it may not be great now, but if you do put some N on and then rest the pasture, you might find those grasses get stronger, so you don't have to use herbicides to take out the weeds. So if we're working on maybe a bit colder, if it's getting a little bit cold or something else is holding the pasture back a bit, you might work on 5. These are sort of typical numbers. And in spring, if we were looking at fodder conservation, you wanted to grow a bit more grass, then often you see numbers like 15 to 20, but I'm not talking about spring today, just about the winter. So if we got a 5-to-1 response and we just, for argument's sake, said we're going to eat all the grass, the extra grass we grow, if urea was $600 a tonne, it's about 25 cents a kilo of dry matter that it's costing us to grow that extra grass, which is about 2.3 cents a megajoule. If we get a good response, like I've easily shown we've been getting at that Bainton site, which is pretty cold in winter, it's 13 cents per kilo dry matter, which is 1.2 cents per meg. And if you compare it to grain at like this recent prices, you might have been paying more than this. 43 cents a kilo of dry matter, 3.3 cents per meg. And if grain's a bit more reasonable price, 0.31. So even if grain was cheap, you can still see, even if we're not getting quite an amazing response, nitrogen at that price can be still cheaper than grain. And even obviously when grain's really expensive, then it becomes an option. But yeah, if we don't have moisture, then we can't use it. We've still got to hand feed. But I suppose that the beauty of, if we've got the moisture and the temperature's okay and we can grow a bit more grass, at least this gives us the option to pull back on the supplementary feeding and hopefully not be doing it when we're lambing, so we don't have to be trail feeding. We can build up enough feed and then we can lamb onto the grass and not have to go near the ewes. Just a little bit on losses from urea, because a lot of work being done in the dairy industry, and just the general wisdom is if we're using say urea when there's actually moisture through the autumn winter, the losses from ammonia volatilisation are going to be quite low risk. In the dairy industry, they're often using nitrogen in the warmer months, so the risk is a lot higher. But I think most sheep beef people, wouldn't be using it in that period, so the losses are going to be quite low. They're only talking 3 to 6% losses in all that work done in the dairy industry, so it's not a lot. And it's still, even if you get a bit of a loss, it's still cheaper than feeding grain most of the time, or hay. So just a bit on any questions on N before I just move on to the GA, and then I'll talk about GA and N, because that was a question that someone had early on. So generally, like I said, if we're thinking it's a bit too cold in our environment, or we're getting too close to when we need the extra feed, we've only got 3 weeks and we're going to lamb, for example, then we might, and it's cold, we're well into June and the temperatures are dropping, and we think N might be too late for an N, then we could look at gibberellic acid. So it works well, when it's colder, too cold for the N to work really well. But gibberellic acid is just it's a natural plant hormone, so it's in the plants naturally in the warmer weather, and when the weather is colder, the levels of gibberellic acid in the plants is lower. Hence, if you put GA onto the plants, it tricks the plants into thinking it's at the warmer time of the year. So what it does is it stimulates cell expansion, so you tend to get leaf elongation, and that increases the growth rate and the kilos of dry matter. It's been around for a long time and used in horticulture. Cyro did some work on pastures back in 1958. They used some pretty high rates, but they got good responses back then, so it looked promising. They were getting like 400 kgs dry matter extra, and that would have been old Australian phalaris in those trials. But back then it was just way too expensive to be able to use. It wasn't a feasible option for pastures in those days. So that's changed now, and it's now quite a cheap product. So where can we use it? So pretty much similar rules to the nitrogen story. We want to have better pastures with a bit of grass in them, good background soil fertility, so same rules as N. And with Phalaris, very responsive, so it doesn't matter which cultivar. The Old Australian responds really well, and the Winter Actives do too. You can get away with 10 grams per hectare. If you're talking perennial rye or cocksfoot, some of the other grasses, it's more looking at 20 grams per hectare. And you can do your own trials and on your place look at what rates you can get a reasonable response with if you're not sure. But these are pretty much the standard starting point on the label, and putting it out in a water rate of 100 litres per hectare. So so the timing's important. The pasture has to be growing. We have to have enough moisture, so we can't have moisture-stressed plants. But we can put it out when it's too cold for good end responses, so June, July up to mid-August, and then it might be getting too warm after mid-August to get really good results. So best results if the air temp's kicking around 5 to 15, an average soil temp above 5 degrees. So we can, like nitrogen, if we're on a rotation, we can graze the pasture off and then put it on after grazing and let that pasture rest for at least 3 weeks, maybe 4 weeks. To get the full growth response before we come back and eat it off. But you need probably a little bit more leaf than you probably get away with nitrogen, just because it's got to go in through the leaves. So I'm saying a minimum of 800. Some stuff you read's 1,000, but most people don't have 1,000 kilos left after they've just grazed the paddock. So you just want some leaf for it to be taken up. Apply to dry leaf, and if we've had a frost, probably just wait a couple of days for the plants to sort of recover a bit. And like I said, if you can take stock out for the 21 to 28 days just to optimise that response, and then it's worked through the plant and then it's ready to go. So this is just at that same site at Baynton, looking at gibberellic acid. People have used gibberellic acid before? Yep. Yeah, so you're all familiar with the colours of the leaves. When you use it, you get the cell elongation, so you're stretching out the chlorophyll in the leaves, in the cells, so it tends to go a bit yellow. So you can see that yellowing there. In this case, grew an extra 200 kgs of dry matter, which is costing 11 cents per kilo of dry matter, or a cent per megajoule of energy. So in this, Phalaris pastures tended to get 200 to 300 kgs of dry matter per hectare extra. The Cyro stuff said 400, the old work did 400 kilos. So, and most other trials I've seen people report on it somewhere of that order, 200, 300, 400. I haven't seen any higher results than that. So you're not going to grow the same bulk that you would with urea. But like I said, if it's got too cold for urea and you're running out of time, then it's still a good option. But I just think you grow more bulk with urea if you can use urea at a good time. But even in subclover, I've had responses on subclover pastures too, and I've seen other work in South Australia where they've used it on medics and got similar sort of results. So most things will respond to some extent. Okay, so got the N, we've got the GA, and then a lot of people are mixing them together, using like easy N products and liquid forms of nitrogen, mixing them together and putting them out then. And that's convenient if they've got their own boom spray, they can put them out together. The liquid nitrogen is a dearer form of N, but you've got that convenience of being able to put them out at the same time. A lot of results I've seen on where we put them together are sort of inconsistent results from where they've been combined. Some trials show no extra response of having them together compared to just GA on its own, and others show up to 300 kilograms. So if we're sort of getting that, if we're putting the nitrogen and the gibberellic acid on together and we're getting 300 kgs extra, that's worth about 15 cents a kilo of dry matter. So it's still a bit more expensive, but still reasonable value for money. So I've just tried to drag out some figures from different trials where they've been used together and looking at the extra amount compared to just using GA on its own. And this is just one, the people that make ProGib have got in their literature, they've grown an extra 200 kgs of grass by putting urea and GA on at the same time and measuring it 4 weeks later. Just some of the work that I've been doing where urea and GA at the same time but measured it 6 to 8 weeks later to give the nitrogen a chance to work through. 80 at one trial, 100 to 200. And then where I used urea at the optimum time and then came back and just put the gibberellic acid on at the optimum time, and then measured it 6 to 8 weeks later after putting the urea on, 30 at one side and 300. And then Andrew Spears ran a trial a number of years ago where he put on nitrogen and GAA at the same time in the mid-June and measured it 3 weeks later and got no response to the nitrogen. And that may be just because it needed another few more weeks for the nitrogen to do something. So if you're coming in after 3 weeks, you're probably just capturing the GA response, where the nitrogen's probably, taking more time to work through the system. So so sort of inconsistent results. And look, like I said before, if you're in doubt, you can always just run some strips out yourself and just check what sort of responses you're getting, just to give you confidence about whether you need to use them in combination or just one at a time. So if you're coming in 3 weeks after they've been applied and then having to graze, that's fine for the GA, it's already done its thing, but you just start diluting out some of the nitrogen, so you're probably not getting the full oomph from your N, and whether there's a little bit left in the soil, I think, because the N pretty much gets into the plant within 2 to 3 weeks, the bulk of it's probably working its way into the plant, so if you're coming in and grazing a bit too soon, you're probably just diluting the overall N response. But but if it's helping you maintain your rotation at all, that's a good thing, because that's a difficulty, isn't it, is trying to keep something going through the winter. Yeah. Okay, so just, look, it's pretty easy to do the sums on the back of a calculator. I mean, you know what the products cost, that's the easy bit. You know what the boom spray costs, you know what the spreader costs. It's often just knowing what the response is going to be. So that's all I've just tried to do today, is just give you some feel for what to expect if you get the timing right and the pastures right. But there is a little calculator on this website, Evergray's website. It's a little ripper, and you can go in there and you can just plug in the cost of urea or the cost of gibberellic acid, or doing both together, whatever you're having a look at, and then just put in a expected response, and it'll quickly work out the cents per dry matter that it's costing you and the cents per megajoule. So you can have a play around that, and then you can look at, well, if I think it's a bit cold for N and I only get a 5-to-1 response, is that still better than grain or hay? You can just play around with those numbers just to give you a bit of confidence whether it's going to be worthwhile or not. Yeah, and by all means, if you're not sure with different rates and things or combinations, do some test strips. It's always really a good idea. To admit, when I've done those trials, I wasn't factoring that into a large extent, and it does get pretty frosty where I did the trials, but that's just best practice sort of recommendation. Yeah. Okay, so just to wind up, importantly, do your feed budget so you can work out how much is that feed gap. Is it a 300 kilo feed gap? Is it a 500 kilo feed gap? And then that way you can say, well, if I plug it in with GA, or what rate of N do I have to use to fill that gap? So if you can do some of that number crunching, that's a good place to start. How fast do you need to feed? Do you need it in a hurry, which is pushing you into using gibberellic acid, I suppose, and maybe putting a bit of N at the same time? What sort of responses are you likely to get? You can certainly grow more kilos of dry matter from urea than you can GA if you can put the urea on at a good time. And look, regardless of which one you're using, you'll get some response, and it usually works out cheaper than feeding grain or hay, even at those variable prices. So, thank you.
Authorised by Victorian Government, 1 Treasury Place, Melbourne.